Record. Shouldn't be full. Okay, let's get to it. So this is a random question that I'm providing for it just to get you to see not only your use of special triangles, but also to work out your fractions, okay? And with CAST rule. Here we go. Sine of pi over 3, so that's 60 degrees, but I'm going to start using radians only, okay? Sine of pi over 3 is root 3 over 2 multiplied by cosine of pi over 3 is 1 over 2 minus tangent of pi over 4, 1, sine of 2 pi over 3, which means the related angle is pi over 3, quadrant 2, so it's a positive. Pi over 3 is sine of 60, which you already did. It's root 3 over 2, positive, plus tangent 3 pi over 2, that's in quadrant 2 CAS, that's going to be a negative. And the related angle is pi over 4, which is a 1. And then, yeah. And then we've got cosine, CAS2, so that's going to be a positive. Related is pi over 3. Pi over 3 is a 1 over 2. Whew. Okay, so we have root 3 over 4 minus root 3 over 2 minus 1 over 2. The final answer is whatever that's going to simplify to. Yes?
I actually have a question about, like, how do you look at sine, like theta or pi divided by 3 and just know that's 3 over 2?
The short answer is practice, but let's see if we can work out a shortcut for you. Okay, so that's manageable. If I could only bring this down a little bit. Here's what I am doing in my head, and at some point I'd like you to be able to do it just so it saves you time. This part you should know, yes? This part's okay, using your special triangles?
Like, I can, like, I have to, like, put it into a angle.
Okay, that's fine.
60 degrees, and then like imagine it.
Yeah, that's totally fine.
But that just takes forever. Fine.
That's 5 seconds is not forever.
But it felt longer than 5 seconds.
But you're right. Pi over 3. I use my cheating shortcut. That's 180 over 3. That's a 60, yes?
Yes.
Now, I don't like this shortcut because it doesn't make any sense, but it does equal to 60 degrees. Sine of 60 degrees, you could either use your chart or you can use your triangle. You'll be able to get root 3 over 2. There's no other shortcut, really. Okay? It is what it is. That's right. The next part is where it should take a little longer. So this is what I've been doing. So this is still 1. Special triangle. Sine 2 pi over 3 is in quadrant 2. How did I get that? Please remember, if that's a 0, that's a pi, and going through again, 0 is the same as 2 pi when it comes to radians. Right? What's between 0 and pi? Well, half of it. And what's between 1 and 2? 1.5. 2 pi over 3, is that equal to, or is that smaller or larger than 1 pi? 2 over 3. 2 over 3. 0.66. It's smaller than 1 pi. So I know it's going to be here. This is quadrant 2, which means what? It's CAST rule. It's going to be a positive value. Next, if this is 2 pi over 3, what's that? Fractions, it's a little annoying, I know. But if you do 180 degrees minus 120 degrees, you would get 60. This is equivalent to sine of 60, aka sine of pi over 3. So if you don't like it, turn it into degrees and solve it. Okay, just turn it into degrees and it's so much faster because you've practiced it last year. But as time passes, I will ask you to get more and more used to radians. Same thing, tangent. Tangent 3 over 4 pi. Is 3 over 4 larger than 1 or smaller than 1? Smaller. I know it's in quadrant 2, CAS. That's going to be a negative value. Tangent of 3 pi over 4 is the same triangle as pi over 4. How do I get that? So 3 pi over 4 is like 3 times 180 over 6. Oh, sorry, 3 times 180 over 4, which is the same as 135 degrees. Where is 135 degrees? Quadrant 2. That's right. Should we do this in degrees? 5 pi over 3. Okay. 5 pi over 3. 5 pi over 3 is 5 times 180 over 3. That's my cheat. That is equal to 300 degrees. Where is 300 degrees? Quadrant 4. So if we're dealing with 300 degrees, what is my related angle? 60. Cosine 5 pi over 3 is the same as cosine of 60. And since this is CAST, that's a positive. Convert, convert, convert. I'm ready to simplify. So this is a long question. Why is this a long question? Number one, well, you're going to have to use CAST rule. And once you use CAST rule, you're going to have to use special triangles. Lots of steps. A question like that could easily be 2 or probably 3 marks. One for proper plus and minuses using, one for proper plus and minuses using CAST rule, one for proper special triangles, and then one for the final answer. Okay. A question like that would easily be 3 marks, easily. So if I'll finish this off. Yes, Riley?
You're never going to give us like a question that's like ask for sine of pi over 8, right?
Sine of pi over 8.
It's always going to be like the ones.
Correct. Sine of pi over 8 is going to be much further down the line. It's called compound angles. So don't worry about it. Don't worry about it.
Like it's just going to be the angles from the special triangles, right?
Yes.
Okay.
There. Yep.
The video that shows the lesson yesterday, which I kind of watched it.
I'll check today. Yes. Sorry about that. That should work. I'll check the video link. Okay. Consider that. This is being recorded as well, so hopefully it'll work today. Any other questions? Any question? Oh, yes.
Can you show how you did the subtraction stuff and the fraction stuff?
For that?
Yes.
Sure. Well, long story short, the numerator is that. And so the root of 3, a radical, because you don't want to multiply that out, consider that like it was a variable. If you had x minus 2x, what would the answer be? Negative x. Same thing. We have negative root 3 minus a 2. You can leave it like that. Yes?
Would this be a good question to practice for tomorrow?
This would be a really good question for us, it's very easy to mark for a teacher's perspective, for sure. And it gets you to do everything. So it's like shows you can use all the skills at the same time. Any other questions? Yes?
Is there anywhere we can find practice with like the radians instead of the angles? Just because the homework is just an angle, but I convert to radians.
Does the textbook have anything?
I think, yeah, maybe, there was like some questions.
There should be some questions from 4.2 from the textbook. I think I assigned it like here. Try those. Yep,
What was the final answer you got this question?
this one here. This, or if you separated it, it would be root 3 over 4 minus 1 over 2. They're both one and the same. Yep.
So that's the same thing as saying, -2 minus root 3 over 4, right? Yeah.
Yes, -2 minus root 3 all over. Yes, correct. Any questions from the cast rule stuff I assigned yesterday? Yep. Number 7. Sure. That's actually more conceptual. I can definitely do that. Snapshot. Hey, a unit circle, use the unit circle to show for which angles A is tan A undefined. A couple of things I can do. I can look at it as judging from my triangle, I can also remember that an angle, tangent of an angle is opposite over adjacent. If you decide to go this route, when is a fraction ever undefined? When the denominator is 0. When is the fraction ever undefined? When the denominator is 0. So if you chose this route, you're looking for angles that make cosine A 0. Or if you chose this route, you're looking for any point on the circle that makes a x value 0. So here is 0, 1. Here is 0, -1. This angle and that angle fits the description. So A equals 90 degrees, pi over 2, or 3 pi over 2. Yes?
I actually have a question about, like, so say you got this angle on test, would you not like draw that dotted line like this to make like that, you know what I mean? And then X.
No, again, no, do it again, try it again, do it
In
again.
my head, I had the same, like, I knew from the chart
Mhm.
that it was 0, but I was trying to figure out like why. It makes sense. It makes sense. No.
I'm so no, I'm ready.
I didn't even know where I was trying to go with that.
As a recap, if you want,
No, it's okay. It's okay.
are you sure? Everything that we're doing, again, in case people still want to use this for cast rule, anytime I have an angle, I am always trying to create an angle with the x-axis. Okay? So if I have this angle, why would I use that angle if I can pretend I have a acute triangle instead?
So if you got like a line that was directly in line with the y-axis, like you're saying like a 90 degree, where would you draw that dotted line?
You don't, because it's not a triangle. Right? You have a very unique circumstance.
But if it's 89.8, it is a triangle?
Correct. So sine of 90 degrees, there's a reason why it's a 0. Sorry, there's a reason why it's a 1. Right? What is the, opposite over hypotenuse? What's the y value if you're up here? 1. What's the radius? 1. It's 1. But if you do sine of 180 degrees, it's a 0 in the calculator. Why? What's my y value when you're here? 0 over 1. It all sort of works out. Yes?
So we're saying the radius is 1 because it doesn't really
And if you have in quadrant 3, why deal with, let's say, 200 something degrees? Why would I deal with that when I can deal with a smaller angle, right? This triangle, and same with this. So while I was helping people during lunch, in case you forgot this relationship with quadrant 1, 2, and 3, and 4, I'm going to give this to you as a refresher. What is the relationship between the original angle and the related acute angle? Well, in quadrant 1, your angle is an angle smaller than 90 degrees. But in quadrant 2, your big fat angle here is the same as 180 degrees minus that small angle. The big fat angle here is 180 degrees plus your small angle. And for quadrant 4, your big angle is equal to 360 minus that little acute angle. And if I had to convert that into radians, well, this is all just pi. Pi minus acute, pi plus the acute, 2 pi minus the acute. This is something that was definitely covered in grade 11. Otherwise, there's no way you would have survived it. Okay? So I hope that you'll be able to brush up and it comes back to you naturally. Any other questions from 4.2? For those of you who haven't tried any questions yet, as a preparation, as a crash course preparation, please consider questions like 4 and 5, because it forces you to look at a Cartesian coordinate as a triangle making device. Okay, so this is quadrant 1 versus quadrant 4. Okay, question 6 is pretty challenging. What else? Number 9 forces you to really look at cast rule. Number 10 is pretty decent too. Just try as much as you can. Bottom line. Okay. Yes, Everett.
So for number 8, I should have been in trouble like knowing where to start with this.
This one you can use a calculator.
We wouldn't get questions down.
No way. All special triangles, all fractions. Any other questions? Yep.
Could you explain 10?
Sure. Question 10. A circle with radius 3 has a terminal arm raised to 30 degrees from the x-axis. In other words, you don't know if it's here or here because it's raised from the x-axis. What is the exact xy coordinate and therefore negative x, positive y coordinate? Can you do it? Yes. Yes, you can. Think in grade 10, if I gave you this, can you tell me what the opposite and the adjacent sides are? This is a grade 10 question. Yeah. If you can, you've automatically found x and y. And if you do this, I believe, let's see, sine 30 degrees is equal to opposite over hypotenuse. Sine 30 is half, is equal to y over 3. Y is equal to 3 times 3 both sides, 3 over 2, 1.5. Cosine of 30 degrees is what? X over 3. So which is, how about I multiply 3 on both sides? I'll do the algebra differently this time. So x is equal to 3 times cosine of 30 root 3 over 2. 3 times root 3 over 2. So there it is. Okay. Therefore, x comma y is 3 root 3 over 2 comma 3 over 2. And negative x over y is negative 3 root 3 over 2 comma 3 over 2. Yes.
When you sub out sine 30 for 1 over 2, you're using just the basic unit triangle.
Special triangle.
Special triangle.
Always.
So
You will
use the hypotenuse of 3 from the
Yeah. So unit circle, the reason why we keep drawing these triangles is because SOHCAHTOA helps us. Like, why not use it, right? Okay. Please practice it. Any other questions? Last call. All right. Then let's take a 5-minute break. When we come back, I'm going straight into this thing. We're going to start this. It's a weird concept. It's not on the quiz tomorrow, so I'm going to try to keep it light, and we'll dig more into it after our quiz tomorrow. Okay? Let's take a 5-minute break. I will pause the video and yeah. Actually, I'll stop the video here so that if you want to use this separately as a 4.2 review, it'll be available for you.